Well, welcome to this week's video. If you don't have your science notebooks, please go get them because you are going to need them as we go through the material this week. So we've been working on the poppers, and what I need to do now is to teach you some of the science behind what's going on and then challenge you to see if you can begin to make sense of what's happening with the poppers. In order to do that, I want to give you a little bit of a history lesson, so here we go. You probably have heard of a man by the name of Isaac Newton. One of the more famous stories about him is he was sitting under an apple tree one day and an apple fell on his head and he came up with this idea of gravity. Well, that's kind of a cool little story. It probably isn't true. He more than likely spent years and years and years thinking about what he had observed related to gravity, and he eventually came up with some ideas about that, wrote those down, shared those with other people, and that's how he was able to begin to describe gravity. He lived from 1642 to 1726. He was born and he lived in England. He was also a Christian, and he said this. He said, "He who thinks half-heartedly will not believe in God, but he who really thinks has to believe in God." As a scientist and as a mathematician, he believed that the natural world that he saw around him was created by God, and he wanted to understand that natural world the best way he could. And so between his belief and his math and science reasoning, he was able to put together the understanding of the world around him. He not only began to think and to talk and write about gravity, but he also began to talk and think and write about motion. So that's where we're going to begin our science lesson today. He's credited with writing 3 laws of motion. We are going to be talking about the first law of motion and the third law of motion. So the first law of motion says this: every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. Now those are Isaac Newton's words. Let's see if we can't put words that maybe are a little easier for us to understand, and indeed there are, and it's this: an object at rest stays at rest unless acted upon by an outside force. There's also another part of that, but it says an object in motion stays in motion unless it is acted upon by an outside force. So the idea here is that when something is at rest, when it's sitting still, it's going to stay there unless some force acts upon it. That force could be you. It could be, some outside force. So look around the room right now and see if you can't find some things that are obeying the first law of motion. Oh yeah, maybe you've got a stapler in your room, or maybe there's a chair in your room. It's sitting at rest and it's not moving because nothing is pushing on it. There's no outside force. Let's think about the other part of this, which is an object in motion. Think about something that's moving, and it's continually moving, and it will never stop moving unless it is acted upon by an outside force. On Earth, we have forces that cause moving objects to eventually stop. Those forces are often, if there's nothing else in the way, that force is often friction. But when we think about things in outer space, like the Earth, for example, it's continually moving around the sun. It's in motion, and according to Isaac Newton's first law, it will stay in motion until it's acted upon by an outside force. He also has what he's called the third law of motion, and it says this: for every action, there is an equal and opposite reaction. So take a look at the picture of the ball right here. If we take a ball and we throw it on the ground, the action is the sort of orange-yellow. We are pushing or throwing the ball at the ground. It hits the ground, and the reaction is it bounces back up off the ground. So we have 2 forces in motion or in play here. We have the first action that's acting upon that object, and then we have the reaction, and those are always equal, but they're opposite. Let me show you that a different way. Let's take a look at the guy on the scooter board. He is going to push against the wall. That will be the action. And what will the reaction be? Right, he's going to go scooting across the floor in the opposite direction. Of course, maybe the way he's seated on that board, he's actually going to tip over. He needs to be more in the middle of the board, but we didn't get to see what actually happened. Take a look at the hammer and the nail. What's really interesting in this one is we don't often think of this, but the nail is actually pushing back on the hammer, and then the hammer is pushing on the nail as well. So the force of the nail is pushing against the hammer, that's the arrow towards the left, and then the force of the hammer is pushing on the nail. And since the forces are equal and opposite, okay, we get that equal and opposite action and reaction taking place. So what I'd like you to do now is to think about the poppers. You've seen two different kinds of poppers. We had the little ones that we just turned inside out, and we put them on the tabletop and they sat there for a while, obeying the first law of motion, by the way, because they were objects at rest, and they were going to stay at rest until some outside force acted upon them. And indeed, there was an outside force, another force that acted upon them, and all of a sudden, we had a demonstration of the third law of motion, because there was an action and an equal and opposite reaction. And the same thing's true with the bigger poppers as well. So what I want you to do in your notebooks is to write a statement that explains how the poppers actually were working in terms of the first and the third laws of motion. Then on the homework page for this week, I have some other web pages that I'd like you to visit. Read those, take some notes on those, and then we'll talk about this first thing next week, and we'll do some more investigations in class. Thanks, you guys are doing a great job. See you next week.